Hello students, welcome to another lecture on logic design. In this video, we are going to learn how to count in octal. As you know, there are 8 symbols in octal, 0 to 7. In this video, we will also cover some basic conversion routines. Octal to decimal, decimal to octal, octal to binary and binary to octal. Let us first learn how to count in octal. In this table, notice that we have 6 columns. The first, third and the fifth column display decimal numbers 0 till 32. The second, fourth and the sixth column display octal numbers for the same decimal number. Let us start from the first column. Notice that the symbols 0, 1, 2, 3, 4, 5, 6 and 7 are octal representations for the same decimal numbers. But once we reach 7, the next octal number becomes 10 followed by 11, 12, 13, 14, 15, 16 and 17. Once we reach 17, the next octal number becomes 20, 21, 22, 23, 24, 25, 26, 27. Once we reach 27, the next octal number becomes 30, 31, 32, 33 and so on till you reach 37. On the next count, it will become 40, 41 and so on. So in this way, we count in octal. Now let's talk about conversions. Firstly, converting octal to decimal. This method uses the positional weights method, a method very similar to conversion of a binary number to decimal. In this method, each octal digit of the number is multiplied by its positional weight and the product terms are added to obtain the decimal number. Let us take an example. 4057.06 to the base 8, convert it to decimal. The positional weights for the integer part of the number are 8 raised to 3, 8 raised to 2, 8 raised to 1 and 8 raised to 0. The positional weights for the fractional part of the number are 8 raised to minus 1 and 8 raised to minus 2. Therefore, the octal number can be written as 4 into 8 raised to 3 plus 0 into 8 raised to 2 plus 5 into 8 raised to 1 plus 7 into 8 raised to 0 plus 0 into 8 raised to minus 1 plus 6 into 8 raised to minus 2. This evaluates to, adding all this up, we get the answer as 2095.0937, which is the equivalent decimal number. Now let's look at how to convert a decimal number to octal. Let's take an example. 378.93 to the base 10 converted to octal. Let us deal with the integer part of the number 378. Just like converting decimal to binary where we do successive division by 2, you can refer to the double-double method. We can convert a decimal number to octal by doing successive divisions by 8 and recording the remainder. So start with 378 and divide it by 8. So we get 8 into 4, which gives you 32. 37 minus 32 is 5. We get left with 58 and then 8 into 7 is 56. So you get 58 minus 56, which gives you a remainder of 2. Again we divide 47 by 8. So 8 5s are 40. 47 minus 40 gives a remainder of 7. Again we divide 5 by 8, but you notice that 5 is too small to divide, so we get the quotient as 0 and 5 gets left as the remainder. Since we've got the quotient as 0, you read the answer from bottom to top. Thus the integer part of the octal number is now 572. Moving on to the fractional part of the same number, recollect that the fractional part of the number is 0.93. Just like converting a fractional decimal to binary where we do successive multiplication by 2, again refer to double-double method, we can convert a decimal number to octal by doing successive multiplication by 8 and saving the integer value of the product. So start by taking 0.93 and multiply it with 8. We get 7.44. Record the value of 7. Next we take 0.44 and multiply it with 8. We get 3.52. Record 3. Again multiply 0.52 with 8. We get 4.16. Record 4. Again multiply 0.16 with 8. We get 1.28. Record 1. Now you can choose to continue this process, but it is advisable to stop after 4 decimal places. Read the final result from top to bottom. Thus the fractional part of your octal number becomes 0.7341 and the final number is 572.7341, which is made up of the integer part and the fractional part. Now let's take a look at octal to binary conversion. Let's take an example. Convert 367.52 to the base 8, convert it to binary. This technique is very easy, provided you remember the 3-bit binary code for the decimal numbers 0 till 7. Recollect the table that I had shown you in the previous video on octal numbers. So let us start converting. Start with octal 3. Its 3-bit binary value is 011. Next we have octal 6. Its 3-bit value is 110. Next is octal 7, whose binary value in 3 bits is 111. Put the decimal points. Now we have octal 5, whose binary value is 101. And last is octal 2, whose binary value is 010. Let us also see binary to octal conversions. Take an example to convert the following binary number into octal. In this method, we simply replace each 3-bit binary code with the corresponding octal number. Refer to the table for the code, but it is better to learn them by heart. So I rewrite the number as it is. Now, starting from the decimal point and moving left, divide the bits into 3 groups each. We get the first group as 111. The next group is 110. And the last group is 11. Notice that it is short of 1 bit. So to make it 3 bits, we add a 0. Now, starting from the decimal point and move right, we get one group as 101 and another group as 010. We have finished dividing the number. Now, replace each group with the corresponding octal number. For 011 we get 3. For 110 we get 6. For 111 we get 7. The decimal point remains as it is. We get 5 for 101 and we get 2 for 010. Therefore, the octal number is 367.52. That's all for now. Connect to the classroom for further videos and learning material.